To create a representative model of a molecule, you have to know the angles between the bonds, and this in 3 dimensions. In our case, we want to build a methane molecule. Methane is a hydrocarbon that bonds 4 hydrogen atoms symmetrically in 3 dimensions. To build this molecule, we need a gauge that represents the angle between the bonds. First, we need to know the angle, and how to get this angle I will explain now. In order to be able to imagine the geometrical conditions of the methane molecule, I have created the following drawing. The first I did was draw a cube. The center of the cube always has the same distance to the corners. There are 8 corners, of which we only need 4, because our methane molecule has only 4 binding arms. If you combine these 4 points, you get a pyramid in the cube, the so-called tetrahedron. Now let's take a look at the angle between the 2 bond arms. Half of the required angle phi, let's call it phi stroke, can be calculated with a tangent function, using the right angle triangle formed by the height of the diagonal of the face. The angle phi stroke equals the inverted tangent of countercathode by ancathode, in which the height is the ancathode and the diagonal is the countercathode. The height corresponds to the edge length, but how to get the value of this diagonals? Since the diagonal forms a right angle triangle with the edges, we can apply the theorem of Pythagoras. The square of the hypotenuse are the diagonal. Here the diagonal is equal to the sum of the Cartesian squares. Here the edges. Since it is a cube, the edge length are equal to, and so the square of the diagonals equals 2 times the square of the edge length. If we pull the root, we get for the diagonal edge length times root of 2. If we put now the values of the height and the diagonal into the tangent function, we get for the angle phi stroke inverse tangent of edge length time root of 2 by the edge length. At least the angle phi stroke will be inverse tangent from the root of 2, nothing else. The value for the phi stroke is 54.75 degrees. This is the angle, the half of the angle. For the total angle, the value has to be doubled, and it is then 109.5 degrees. To simplify the construction of the gauge, we only look at the diagonal face. It consists of a rectangle formed by the height as one side length and the diagonal of one face as the other side length. No matter what edge length of the cubes has, the corresponding diagonal has the same length multiplied by the root of 2. Here's the example. If the edge length of the rectangle is selected with 15 centimeters, the other edge length is root of 2 multiplied with 15. This would be 21.2 centimeters. Now the diagonals are drawn into this rectangle and you get a triangle with an angle of 109.5 degrees, as it is needed for the gauge. Now the radius of the object representing the carbon atom has to be drawn, and the first of 3 sides of the gauge can be cut out.
So right now I have my three parts of my gorge, and I have to connect them. So the first two I will paste together on here. Ready. Now the second one over here. Okay. Now it's two-dimensional by rising up this part and pasting it together. First, I put my scotch on one side. So right now it's connect 6 and have a guideline to get in my C atom. So right now, here I have my foam ball with 50 millimeters in diameter. Let's take it around like this. Now I take my toothpick from this side with this angle and stick it in the foam ball over here like this. Now the second one, I'll turn around, always take care that this will stay on its place. I could paste it there, but right now, look over here. I come from this side, sticking here. And the last one, always look that you stay in the line of the others over here. Oops. So it's too strong a little bit. Okay, like this. You see? And then I turn it around and one bond gets up. So I can take the last one, the fourth one, from this side and ready. Yeah. I have my carbon atom with 4 bindings, always in 109.5 degrees angle and the same distance. Okay, that's it. Have fun building up your own model.